In a groundbreaking discovery, scientists have found evidence suggesting the possible existence of parallel universes. After decades of theoretical debates, this discovery also has revolutionary significance. What did they discover? And how do these clues challenge our understanding of reality? Could there really be another version of you? In today's video, we will explore this incredible story and reveal the hidden evidence that suggests the existence of parallel universes. The concept of parallel universes has unfolded like the wings of science fiction since the early 1960s, appearing in countless television shows and comic book stories. However, now it is beginning to emerge from the mist of fantasy to become a shining gem in the temple of science. Imagine a place where a universe intertwines with ours, but with a completely different history, where every particle may have a different version of us. Perhaps this version of us is living a completely different life than our own right now. In fact, the concept of parallel universes is not just a fantastical construct, but has become the holy grail for scientists and storytellers. As early as 1954, a young graduate student from Princeton University proposed this revolutionary theory of parallel realities. These realities are closely linked to our world, but follow different paths at the crossroads of fate. This theory is also known as the many-worlds theory. It is like a key that tries to unravel the puzzling mysteries of quantum physics. Since its proposal, many scientists have regarded it as speculation, dismissing its credibility. The idea that each quantum transition could generate an infinite number of new isolated universes sounds like a fairy tale. Hard to believe. But this theory is like a brave explorer embarking on the journey to unravel the unknown domain of quantum mechanics. To understand why this theory causes so much controversy, we need to dive into the mysterious depths of quantum physics, a field full of surprises that often defies our perception of reality. Quantum particles, like photons, behave like mischievous children, unpredictable and elusive, sometimes displaying themselves as particles and at other times as waves. This surprising phenomenon is skillfully described by Heisenberg's uncertainty principle. And Heisenberg's principle is like a double-edged sword that reveals the profound impact of observation itself on the quantum world. Another great physicist, Niels Bohr, unraveled part of the mystery of the quantum world, arguing that quantum particles, before being observed, exist in all possible states like ghosts. The many-worlds theory goes even further, proposing an astonishing idea. The universe does not reveal its true nature only when observed, but splits into countless parallel universes at every moment of observation, each of them being an independent reality, carrying different possibilities. Although this theory shook the scientific world like a storm, it also faced many doubts, with countless scientists finding it hard to believe in the idea of countless parallel worlds, considering it an absurd fantasy. However, the controversy did not stop the spread of the concept of parallel universes. Like a seed, it has taken root in the fertile soil of science, triggering countless theories and experimental explorations. The enthusiasm surrounding this discovery is overwhelming. If parallel universes really exist, it would completely revolutionize our understanding of reality and make us rethink our place in the cosmos. Imagine countless parallel worlds, like reflections in a mirror, each carrying a different story, different events, and even different versions of ourselves. This discovery is not only a significant advancement in science, but also a profound insight into the mysterious nature of the universe. Evidence supporting the existence of parallel universes is emerging like morning stars, suggesting that we are close to uncovering the secrets of the universe that we have long sought. However, a shocking announcement to the scientific community caused a great stir, like a stone thrown into a calm lake. NASA scientists conducted a spectacular cosmic ray detection experiment in the icy lands of Antarctica. This experiment, like a daring explorer, traversed the endless ice field in search of mysterious particles from outer space. A huge balloon carrying a sensitive electronic antenna, like the eye of the universe, looked into the cold, dry sky, trying to capture the purest data in the ocean of radio noise. During their observations, a surprising discovery tore through the silence like a lightning bolt. They detected particles called tau neutrinos. These particles seem to violate the laws of physics as we know them, moving up from the Earth like fish swimming against the current, contrary to our understanding of subatomic particles in the universe. Normally, high-energy particles fall from space like meteors colliding with the Earth. However, these tau neutrinos, as if they were traveling back in time, emerge from the Earth, pointing to a possible parallel universe. This discovery caused a great commotion in the scientific community. It challenges our traditional understanding of the universe, forcing us to re-evaluate the cosmos that seems ordinary but is full of mysteries. The behavior of these particles is like ghosts in a maze, leaving scientists perplexed. They can only speculate that these particles may have come from a parallel universe. This discovery adds a new level of interest and excitement to the field of cosmology, as if a mysterious touch had been added to a vast cosmic painting. Scientists continue to explore this unknown vastness like brave navigators, hoping to discover the truth behind these particles. But that's not all. Under the watchful eye of the European Space Agency's Planck telescope, the map of the cosmic microwave background radiation is like an ancient map that reveals the remnants of the Big Bang. This map is like a diary of the universe, recording the details of its birth. By analyzing this data, Caltech cosmologist Rongaram Cherry discovered a strangely bright region. This discovery is like finding an unknown continent on a map, arousing curiosity and anticipation. Cherry's hypothesis shines like a star in the night sky. He firmly believes that interactions between universes may be reflected in this strange bright region, suggesting a subtle encounter between our universe and another. These areas of intense brightness, as if they were remnants of an encounter between our universe and a parallel universe, could be evidence of a brief crossing between them, like shooting stars leaving trails that we can investigate. The bright region that Cherry observed may be one of these clues, whispering about an indescribable encounter between our universe and others. This hypothesis gains even more mystery in light of the theory of cosmic inflation. Since its birth, the universe has been continuously expanding, like a heart that never stops beating in the infinity of darkness. According to this theory, this rapid expansion may be the creative force of countless bubble universes. Each universe is like an independent dream, with its own laws and characteristics. The discovery of the Planck telescope reveals a fascinating chapter about the possibility of parallel universes. If this hypothesis is confirmed, our universe would be just a speck in the vast starry sea, with countless universes quietly living their stories in unknown corners. The idea of other realities, of other versions of ourselves, is both exciting and hard to believe. Imagine, beyond the infinite universe, there may be countless other universes waiting for us to be discovered. The theory of cosmic inflation is the key to understanding all this. It tells us that in the early moments, the universe went through a frantic expansion, like a big bubble that suddenly expands, smoothing all the irregularities and making the universe incredibly harmonious on a large scale. MIT cosmologist Alan Guth, who proposed the inflation theory, painted a picture of the universe full of possibilities. He believes that the energy that drove inflation did not completely dissipate, but remains active in some regions of space, creating new inflationary space bubbles. Each of these bubbles could be a new universe, with its own physical laws and properties. This is the concept of a multiverse, or multiple universes. In the vast and infinite cosmos, these universes, created by the same Big Bang, are like bubbles in a symphony, each independent yet in harmony, like bubbles floating in a great cosmic foam, looking at each other but unattainable. The expansion of the universe weaves a vast tapestry of multiverses, while quantum mechanics adds details of parallel realities to the picture. Quantum mechanics, which explores the mystery of particles in the microscopic world, often challenges the most fundamental intuitions. The double-slit experiment is a classic example that reveals the strange behavior of the quantum world. In this experiment, particles are shot at a barrier with two slits, but the pattern that forms is like a puzzle in the mirror, showing a wave characteristic that passes through both slits at the same time. This phenomenon is like a magician showing his tricks, confusing and surprising. For proponents of the many-worlds theory, the double-slit experiment is evidence of the unfolding of a parallel universe. They believe that each quantum event is a fork in the path, with each choice creating a new reality, like diverging paths in a dark forest. If the many-worlds theory is true, then every decision we make, every quantum transition, is creating new universes. These universes exist alongside ours, but are unattainable, like reflections in a mirror, looking at each other, but never touching. These parallel universes, like leaves falling in the wind, each carrying a different version of ourselves, spread across the vast cosmos, like starlight reflected in the water, shining and fading. The journey to find the multiverse is like navigating an unexplored sea, where science and imagination intersect, like a map guiding the brave to unknown worlds. If the multiverse really exists, then the story of humanity is just one of many stories, like a grain of sand in the vast desert. Whether a parallel universe, a multiverse, or another unknown form, the exploration of the unknown has always brought infinite possibilities and hope to humanity. The concept of parallel universes makes us reflect on the infinite and the unknown, forcing us to face our own insignificance and encouraging us to explore the stars more deeply. No matter what the final outcome is, this journey towards the unknown will always be a great adventure. As we look at the vast universe, we hope that somewhere, perhaps another me is thinking about us. Until next time, keep exploring the unknown.